Good morning to all. Myself, Dr. J.J.Jayapal, Assistant Professor, PG and Research Department of Computer Science, St.Joseph College of Arts and Science, Autonomous, Cuddalore. Okay, today we are going to see the data communication and the network. The main topic is networking and the internetworking devices. First, we will see the networking. The two or more devices connected for the purpose of sharing data or resources can form a network. Internetworking. Two or more separate networks are connected for exchanging data or resources. They become an internetwork. So connecting devices. The connecting devices are classified into one is the networking devices, another one is the internetworking devices. The networking devices are repeaters, bridges. The internetworking devices are routers and gateways. The first one is the repeaters. The repeaters. A repeater is an electronic device that operates on only the physical layer of the OSI model. A repeater allows extending the physical length of a network. A repeater is not an amplifier. It does not amplify the signal. It regenerates it. When it receives a weakened or corrupted signal, it creates a copy bit for bit at the original strength. A repeater must be placed so that a single reaches it before any noise changes the meaning of any of its bits. So that is a diagram for a repeater in the OSI model. The repeater is placed between the device A and device B. The repeater is working on the physical layer alone in the OSI model. So that is a repeater. The repeater is connecting the two different LANs. The A and B is one LAN network. D and C is another network, LAN network. We are connected by the repeaters. The function of a repeater. The A diagram is representing the data transferred from right to left. The corrupted signal is transferred through the repeaters. The repeater is regenerating or strengthening the signal to the device B. Likewise, the signal is transferred from left to right transmissions. The corrupted signal sent through the repeaters. The repeater is strengthening the signals. The next one, bridges. The bridges operates in both the physical and data link layers of the OSI model. Bridges can divide a larger network into smaller segments. They can also relay frames between two originally separate LANs. The bridges contain logic that allows them to keep the traffic for each segment separate. It also provides security through partitioning of traffic. So that is a diagram for bridges. A bridge in the OSI model. The device A and device B, we are connected by the bridges. The bridges are working on the first two layers of the OSI model. The first layer is the physical and the second one is the data link layer. So that is a diagram. It is connecting the two different LANs. That is a B, C and D is that is a one network. E, F, G, H is another one LAN network. We are connected by the bridges. So here, so the different LANs we are connected. The data is transmitting from A to D, and then we are also connected the one LAN, that is a one segment to another segment. So here the another one diagram, the B diagram, a packet from A to G. That is the A and D is the one segment. F and G is another segment where data is transferred from segment 1 to segment 2. That is the device A to G. So we are using the different bridges. The one is the simple bridge, multi-port bridge and transport bridge. Simple bridge. A simple bridges are the most primitive and least expensive type of bridge. A simple bridge links two segments and contains a table that it lists the addresses of all the stations included in each of them. So next one is a multi-port bridge. A multi-port bridge can be used to connect more than two LANs. Here, that is a LAN 1, LAN 2, and then LAN 3. So we are connected by the LAN 1 and LAN 2 is by the bridges. And as well as the LAN 3 also we are connected by the bridges, that is called the multi-port bridge. Transparent bridge. A transparent bridge is otherwise called as learning bridge. It builds its a table of station on its own. Transparent bridges use spanning tree algorithm or source routing to avoid loop. A bridge will be able to connect LANs using different protocols at the data link layer, such as Ethernet LAN to a token ring LAN. It addresses many issues which include frames format, payload size, data rate, and addresses bit orders, other issues such as acknowledgement, collision, and priority. The internetworking devices. First one is the routers. The routers. Routers relay packets among multiple interconnected networks. The router forwards the packets to the next router on the path and so on until the destination is reached. The routers act like station on a network. The router checks the destination address, finds what is considered the best route for the packet, and passes it to the destination network or across a neighboring network to the next router on the chosen path. So that is a diagram for routers. So device A and device B. The device and device B is connected by the router. It is through the networks. It's only working on the first three layers of the OSI model. The first layer is a physical, second layer is a data link, third layer is a network layer. So that is a diagram is how to connecting the different LANs by using the router. So that is a one bus, that is a one type of topology, and then ring, and then bus topology, and then ring topology, and then ring topology. We are connecting the one topology to another topology by the router, and then likewise the ring to bus we are connected by the router, and then ring to ring we are connected by the router, and then ring to bus topology we are connected by the routers. So least cost routing. The least cost routing is based on efficiency, which of the available path is the cheapest or shortest. The shortest means the smallest number of relays. It is called hop count routing, in which every link is considered to be a equal length and given the value 1. One hop routers are equal to 1, two hop routers are always equal to 2, and so on. The types of routing. Routing is classified as non-adaptive or adaptive. The first one is a non-adaptive routing. In non-adaptive routing, once a pathway to a destination has been selected, the router sends all packets for the destination along that one route. The adaptive routing. In adaptive routing, a router may select a new route for each packet is a response to change in condition and topology of the networks. Pocket lifetime. Pocket lifetime or time to live is added with every pocket. As a pocket is generated, for each pocket is marked with a lifetime. Usually the number of hops that are allowed before a pocket is considered lost and accordingly destroyed. Each router to encounter the pocket subtract 1 from the total before passing it on. When the lifetime reaches 0, the pocket is destroyed. The next one, internet networking devices, gateways. The gateways operate on all seven layers of the OSI model. A gateway is a protocol converter. A router by itself transfer, accepts, and relays packets only across networks using similar protocols. A gateway can accept a packet formatted for one protocol and convert it to a packet formatted for another protocol before forwarding. A gateway is generally software installed within a router. In some cases, it modifies headers and tailors of the packet. In other cases, it adjusts data rate, size, and format. So that is the gateway diagram in the OSI model. Device A and then device B is connected by the gateway in the networks. The gateway is working on all the 7 layers of the OSI model: the physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and then application layers. So that is a diagram. We are connecting the different two networks, the SNA and then network are connected by the gateways. Okay, thank you.